Welcome to Module 1, Lesson 4, Positivism and Post-Positivism. Today, we explore two foundational paradigms that have profoundly shaped scientific research as we know it. These paradigms represent not just methodological approaches, but complete worldviews about the nature of reality, knowledge, and how we can understand the world around us. Positivism emerged as the first systematic attempt to apply scientific methods to all forms of knowledge, while post-positivism evolved as a sophisticated refinement that acknowledges the complexities and limitations of scientific inquiry. Understanding these paradigms is crucial because they continue to dominate much of contemporary research, particularly in the natural sciences and quantitative social sciences. As we journey through this lesson, I want you to consider how these paradigms manifest in your own field and how they shape what counts as legitimate research. By the end of our 10 minutes together, you'll understand not just the principles of these paradigms, but also how they evolved from certainty to critical realism, and what this means for contemporary research practice. Our learning objectives today build progressively to give you a comprehensive understanding of these influential paradigms. First, we'll identify the key principles of both positivism and post-positivism, understanding their core assumptions about reality, knowledge, and scientific inquiry. Second, we'll compare and contrast these related paradigms, examining how post-positivism emerged as both a critique and refinement of positivist principles rather than a complete rejection. Third, we'll analyze the methodological implications of positivist assumptions, exploring how these philosophical positions translate into concrete research practices, from experimental design to data analysis approaches. These objectives will equip you to recognize positivist and post-positivist assumptions in research you encounter and make informed decisions about when and how to apply these paradigmatic approaches in your own work. Understanding these paradigms is essential for navigating contemporary research as they continue to shape standards for rigor, validity, and scientific credibility across many disciplines. Let's begin with the historical development of positivism, tracing its evolution from a revolutionary idea to the dominant paradigm of scientific research. Auguste Comte, writing in the 1830s, founded positivism as a systematic approach to understanding not just the natural world, but society itself through scientific methods. Comte believed that human knowledge progresses through three stages: theological, metaphysical, and positive, with the positive stage representing the pinnacle where knowledge is based solely on observable facts and scientific methods. His vision was ambitious: to create a unified science that could explain all phenomena through the same fundamental principles. The Vienna Circle of the 1920s took Comte's ideas further, developing logical positivism with its verification principle, the idea that statements are meaningful only if they can be verified through direct observation or logical proof. This group of philosophers and scientists sought to eliminate metaphysics entirely from scientific discourse, creating a pure science based on logic and empirical observation. The core principles that emerged from this tradition include the belief that only observable phenomena constitute valid knowledge, that the scientific method is the only legitimate path to truth, and that universal laws governing all phenomena can be discovered through systematic observation and experimentation. Understanding positivist research assumptions requires examining how this paradigm views the fundamental questions of research philosophy. Ontologically, positivism assumes a single, objective reality that exists independent of our observations. There is one truth waiting to be discovered, and this truth remains constant regardless of who observes it or when. This realist ontology suggests that the world operates according to natural laws that can be discovered through scientific investigation. Epistemologically, positivism champions observer independence and value-free inquiry, believing that researchers can and should remain completely detached from their subjects of study to avoid contaminating findings with subjective bias. Knowledge is seen as objective facts that can be verified through sensory experience and logical reasoning. Methodologically, positivism favors experimental designs, quantitative measurement, and deductive reasoning, starting with theories and hypotheses that are then tested through controlled observation. The quality criteria reflect these assumptions. Internal validity ensures that observed effects are due to manipulated variables. External validity allows generalization to broader populations. Reliability ensures consistent results across time and observers. And objectivity guarantees that findings are free from researcher bias. These assumptions create a coherent framework for pursuing certain verifiable knowledge about the world. Post-positivism emerged in the mid-20th century as philosophers and scientists began recognizing the limitations of pure positivism, with Karl Popper leading this intellectual revolution. Popper's principle of falsification fundamentally challenged the positivist notion of verification, arguing that we can never prove theories true, only demonstrate they are false. This shift from verification to falsification transformed how scientists think about knowledge. Instead of accumulating proof, science progresses by eliminating false theories, with surviving theories being provisionally accepted until falsified. Popper introduced the concept of critical rationalism, acknowledging that while objective reality exists, our ability to know it is limited by our sensory and cognitive capabilities. This evolution represents not a rejection of scientific methods, but a more sophisticated understanding of their limitations. Post-positivism recognizes that all observation is theory-laden, that complete objectivity is impossible, and that scientific knowledge is always provisional and subject to revision. The critical realist ontology of post-positivism maintains that reality exists independently of our perceptions, but acknowledges that our understanding of it is mediated by our theoretical frameworks, methods, and human limitations. This paradigm accepts uncertainty as a fundamental aspect of scientific knowledge, while still maintaining that systematic inquiry can produce useful, if imperfect, understanding of the world. Post-positivist research approaches reflect this more nuanced understanding of scientific inquiry through modified assumptions and expanded methodological options. Ontologically, post-positivism embraces critical realism. Reality exists, but is only imperfectly and probabilistically knowable due to human limitations and the complexity of phenomena. We can approach truth, but never fully grasp it, and our understanding is always mediated by our theoretical lenses and methodological choices. Epistemologically, post-positivism acknowledges modified objectivity, recognizing that complete detachment is impossible, but that bias can be acknowledged and controlled through various strategies. Researchers are seen as bringing unavoidable perspectives to their work, but these can be managed through reflexivity, peer review, and methodological rigor. Methodologically, post-positivism champions multiple measures and triangulation, using diverse methods to approach phenomena from different angles and build more robust understanding. This includes mixing quantitative and qualitative approaches, using multiple data sources, and employing various analytical techniques. Quality criteria expand beyond simple validity and reliability to include catalytic validity, ecological validity, and other forms that recognize the complexity of real-world research. This evolution represents a maturation of scientific thinking that maintains rigor while acknowledging complexity and uncertainty. Comparing positivism and post-positivism reveals both continuities and important differences that have profound implications for research practice. In terms of reality, positivism asserts a single, objective truth that can be fully known through proper methods, while post-positivism acknowledges reality exists but is imperfectly knowable due to human and methodological limitations. Regarding knowledge, positivism claims certain and verifiable knowledge is achievable, whereas post-positivism views all knowledge as probabilistic and fallible, subject to revision as new evidence emerges. The observer's role differs significantly. Positivism demands complete detachment to ensure objectivity, while post-positivism recognizes that bias is inevitable but can be acknowledged and controlled. Methodologically, positivism traditionally relies exclusively on experimental methods and quantitative measurement, while post-positivism embraces multiple methods and triangulation to build more comprehensive understanding. Truth claims represent perhaps the most fundamental difference. Positivism seeks to prove theories true through verification, while post-positivism focuses on falsifying theories, accepting that we can never prove absolute truth. These differences aren't merely philosophical abstractions, but translate directly into how research is designed, conducted, and evaluated, influencing everything from grant proposals to publication standards. The methodological implications of these paradigmatic differences are profound and shape every aspect of the research process. Research design evolves from rigid experimental protocols in pure positivism to more flexible approaches in post-positivism that can adapt to emerging insights and complex real-world conditions. While controlled experiments remain valuable, post-positivism recognizes their limitations and incorporates quasi-experimental designs, natural experiments, and mixed methods approaches. Data collection shifts from relying on single methods assumed to capture objective truth to triangulation strategies that use multiple data sources and collection methods to build more robust understanding. This might include combining surveys with interviews, observations with experiments, or archival data with field studies. Analysis moves from purely statistical approaches aimed at proving hypotheses to mixed analytical strategies that might combine statistical testing with qualitative analysis, meta-analysis, or computational modeling. Interpretation transforms from claims of certainty and universal laws to probabilistic understanding that acknowledges confidence intervals, effect sizes, and the provisional nature of findings. These methodological implications mean that post-positivist researchers must be more sophisticated in their methods, more humble in their claims, and more transparent about limitations, while still maintaining scientific rigor. As we conclude this lesson, I invite you to engage in critical self-reflection about these paradigms and their influence on your thinking about research. First, consider which positivist or post-positivist assumptions you find most compelling and which you question. Do you believe in a single objective reality? Or do you see reality as more complex and multifaceted? Are you comfortable with the uncertainty inherent in post-positivism, or do you prefer the clarity of positivist claims? Second, examine how positivist approaches have influenced research standards in your discipline. What counts as rigorous research, what methods are privileged, and what types of knowledge are valued. How might these standards reflect historical paradigmatic commitments rather than inherent superiority? Third, imagine how adopting a post-positivist perspective might change your approach to a research question you're interested in. Would you design your study differently, use different methods, or interpret your findings with more nuance? These reflections are crucial for developing paradigmatic awareness and making conscious choices about your philosophical positioning, rather than unconsciously adopting disciplinary defaults. Let me leave you with 4 key takeaways that capture the essence of positivism and post-positivism and their significance for contemporary research. First, positivism seeks objective truth through scientific methods, believing that careful observation and experimentation can reveal universal laws governing natural and social phenomena. This paradigm established the foundations of modern science and continues to influence how we think about rigorous research. Second, post-positivism acknowledges the fallibility and limitations of scientific knowledge, recognizing that while reality exists independently, our understanding of it is always mediated and provisional. This represents a maturation rather than rejection of scientific thinking. Third, both paradigms shape methodological choices profoundly, from the questions we ask to the methods we use to the claims we make about our findings. Understanding these influences helps us make more informed decisions about research design. Fourth, the evolution from certainty to critical realism represents a broader shift in scientific thinking, from absolute claims to probabilistic understanding, from proof to falsification, and from detachment to acknowledged subjectivity. As we move forward to explore interpretivist and constructivist paradigms in the next lesson, remember that these positivist traditions remain influential and valuable, particularly for certain types of research questions, while their limitations open space for alternative approaches to knowledge creation.